Hi, welcome to the Stars Tutoring Chatbot. My name is Leandro Alvarez, and I'm accompanied with Brian Otero, Christian Vasquez, Miguel Garcia, and Jesus Valdez. So let's start off with our problem statement. What is STARS? Well, STARS is an FIU program that provides tutoring assistance for students taking computer science classes. The main limitation that we have is that tutoring is limited to appointed sessions. It's not like a 24/7 system. Um, and so the objective was to create class-specific AI-powered chatbots. So it would be a chatbot app where you can communicate with different models that are trained on different classes, right? So let's move forward with what the previous project iteration accomplished. So the previous iteration, they started the process of creating the web app and also using the fine-tuned models in few-shot learning. So the few-shot architecture, imagine that as question-answer pairs that would be used to actually influence the model's behavior. So when a user queries the model, the most relevant examples would be extracted using similarity search from LangChain, and these relevant examples were then fed as context to the LLM. So this is what the previous iteration accomplished with their architecture. However, they only had two fine-tuned models, TutorBot and CodeBot. The chat history was not being saved, and the model training data was being stored in a JSON, not a database. There was no database design, and it only stored basic user information. So this is the context from the previous iteration. Moving forward to our technical overview, our front end was Streamlit, our backend logic was just Python with LangChain, our database was MongoDB. We did accomplish deployment. While we would have preferred deployment on AWS, we were restricted from doing this. We were told to leave it to the next semester. However, as a temporary solution, we decided that we wanted to deploy a database and web app on a Raspberry Pi using Tailscale as a VPN. A few LLM integrations, we used OpenAI and Grok API and the LangChain framework as well. And now I'll leave the system design to Chris.
All right, thank you, Leandro. So now moving on to the system design. Essentially, the design that we chose was for in the database for users to store their chat history, courses, and even store the current courses that tutors are allowed um, to tutor and help out the students, as well as the archiving of chats. Now, for the chat histories, they're always going to be sorted by the timestamp. So let's say a user wants to update a chat from like 2 weeks ago. Once they update that, it'll move right on top of the stack. And we also implemented some caching for the chat histories to improve the latency on the Streamlit app, as well as some password hashing on the security feature.
Hello, this is the main page of the web app. This is where student users and tutor users can talk to chatbots like TutorBot, CodeBot, and class-specific bots. These bots will get user-guided responses instead of direct answers. Users can access the class-specific bots based on their course enrollment, and all these chats will be archived at the end of the semester to comply with the FERPA requirements. The page allows the users to add or delete a chat as well as logging out as well. For tutors, they have an option to fine-tune the selected chats to improve the selected chat models within the web app. To talk more about fine-tuning, I'm bringing it back to Leandro.
Okay. So throughout this project, we established an architecture for creating new models, but also for continuously training the models based on tutor input. So the tutors would log in and they would answer a few questions, and then that would be used to fine-tune the model. The way it starts, so we had to start, the tutor selects a model. They then answer the questions. The questions then provide two different types of data. So on the one hand, it gives us examples, which are going to be used for the few-shot learning. And it also creates completions, which is the training data that would actually improve the fine-tuned models. So those completions would then be stored within our database, and at any point, the fine-tuning can be triggered, which would then update the model with that learning. Moving forward towards enrollment, I'll give it to Miguel.
Yeah, so for enrollment, within our web application, we have three main user types. We have student, admin, and tutors. The enrollment feature mainly applies towards the student and tutor side. Um, for the student side, a student can be able to sign up and create using their own FIU credentials, so using their FIU email and whatever personal password, and they would have to insert their own course schedule in order they have to insert their own course schedules for to see the available courses that they can get tutoring services from the chatbots. And then depending on the admin side, it will have to depend on what courses are currently available that STARS is giving services for the admin tutor approve or reject the student's course selection. And even so, the admin still has the ability to either reject or still accept the student given the course selection. And then on the tutor side of enrollment, ideally, STARS would have a meeting with upcoming tutors and would hand out an authentication code for each tutor for their general sign up. And for their sign up, they can also use their general FIU credentials, such as email and whichever password they choose, as well as the authentication code. And then on the admin side of things, it's on their end to either accept or reject the upcoming tutor. And then moving on to the admin panel.
And for the admin panel, first you will see the course page. Here, you will be able to see every course offered by STARS. There, admins are able to add or remove any courses. Also, going forward, they will be able to see the pending students. Admins are able to approve or reject any pending students into a program, and then in which the program then sends an email to the students automatically with a decision. For enrolled students already, admins have the ability to remove them, download their chats, or make them go back to upload their courses again. Also, at the end of the semester, the admin has the ability to archive all chats. This is a FERPA requirement, which also prompts the users to go back and upload their new semester schedule. Now for deployment.
All right, thank you. So continuing on with deployment, continuing to what Leandro mentioned beginning of the presentation, due to the decision that the PO made, we weren't allowed to essentially host the application on an official AWS instance. So instead, we used a dummy domain with a dummy EC2 instance. Essentially, this EC2, which is you can think of it as the client side, communicates with the Raspberry Pi 4, which is the hosted MongoDB database. The way they communicate with each other is essentially through the Tailscale VPN, which acts as a middleman between them. Now moving on to the individual contributions.
Okay. So my role in this project was as a team lead. I worked on several features such as the system design, the multi-chat storage feature. I developed the fine-tuning feature for continuous model training. I worked on the architecture for student and tutor enrollment. I worked on the admin panel side for user approval, user administration, course administration, and chat archiving. And I also worked on automating the emails to users after an admin decision using the Bravo API. Now for Brian.
Hello. I was the Scrum Master and developer for this project as well. The user stories I worked on is the new chat feature, the select chats with the little blue dot, and then every for a chat summary as well. For a user, if they ever type a response, they'll update the title of the button to give more accurate responses. And then we also have improving load times as well. I improved the load times between the selected bots, the selected chats, and then for add new button as well. And then I also made the completions and examples for operating systems.
All right. So the role that I played for this project was the developer role. Some of the user stories that I worked on were creating a class bot specifically fine-tuned for the algorithm techniques course. So I just created following a certain format, completed the completions and examples and fed it to the model. For security reasons, I also implemented a password hashing for all users, including admins, tutors, and students. I also implemented some caching for the chatbot chats, in order to optimize the streamlit latency. I also migrated the local DBs that we each had on our devices to a hosted MongoDB instance on my Raspberry Pi 4. And in order for my teammates or users to connect and interact with that DB, I had to set up a VPN using Tailscale Tailnets. And essentially that Raspberry Pi 4 is being fetched through the private VPN. But the one that's fetching it is the deployed application for the dummy EC2 instance that is currently running on a TMUX session.
Yeah, and as for my own individual contributions, I initially worked on a fine-tuned model for computer architecture, again, also using completions and examples. Um, and in terms of the Streamlit development, I devised the initial page for the admin panel where the admin can add or erase courses, and also have the initial feature of either rejecting or accepting upcoming students, as well as changing it on the backend side for the Mongo as well. Also developed the initial instance of the multi-chat feature, so that it wouldn't be just like a singular chat that the students and tutors can mess with. And lastly, I also devised the initial schema for the student role, what the student would have, such as the chat history, chat responses, chat responses. Um, and over time, I also developed the general schema for how the Mongo will handle different user types, such as admins, tutors, and students.
Lastly, for me, I work on the starting structure of the database and also help on improving the UI design and the latency of the web app. As the rest of my teammates, I also worked on examples and completions for a class bot. In my case, the logic of computer science bot. Finally, I contributed into the development of the admin panel, helping in the implementation of the approval and rejection feature. Now for our challenges.
Yeah, throughout this project, we had quite a few challenges. So, firstly, it was from the framework itself. It had a few limitations, such as lack of styling, lack of components, and a lack of a more dynamic state management. Although we struggled at times to find workarounds due to Streamlit's limitations, we found the best solutions possible. We also had some challenges with the fine tuning. We found that the continuous model training would actually be too expensive. So therefore, the solution was to store the training data and trigger it later. So that way it's not that expensive. We also found that automating the emails, it would not send it to the FIU domain. And this is because we need the DNS records from the IT department. And we ran out of time for this. But the system is in place and future students just need to acquire this information and then it would work. Lastly, we were unable to integrate the FIU SSO. Although we did request this early in January, it was received very recently, and so we didn't have enough time to integrate the SSO as well for student authentication. Now moving towards future plans. So in our future plans, we want to integrate the FIU SSO. Well, not us, but future students. The future students would also ask for DNS records from the IT department to automate the emails. They would also create a developer app for triggering the fine-tuned models. And lastly, they would deploy the database and web app on AWS using a private link, the AWS private link as a secure endpoint. Lastly, our acknowledgements. We want to thank Dr. Wells and Andres Lopez, our product owners. And that would conclude our presentation. Thank you.
Thank you.
Thank you.